Hvala vam lijepa. Hvala svima koji su prezentirali svoje postere. Uz podsjetnik naravno da sve poster prezentacije tijekom stanki možete vidjeti i u dvorani Zrak. A sada je stigao na red i na našeg drugog pozvanog predavača. Giorgio Rossi, professor of physics at the Università degli Studi di Milano and representative of Italy in the EOSC Steering Bord, will give a second keynote on this third day with the topic, the challenge of digitalization of research, interoperability of research infrastructures, and access to fair data for exploiting automated research workflows. Professor Rossi will talk about the role that the key elements of open science, namely fair data and data services for research, have within EOSC, and what their role is in strengthening the interoperability of research infrastructures. Welcome, buongiorno and benvenuti.
Thank you very much. Thank you very much for the kind invitation, and immediate apologies because I made some fundamental mistake in the arrangement of the slides. So only some of the slides will be useful, but I will try to make the point of the topic. So challenge of digitalization of research. So this is something that we are preparing to in different ways. One way is, of course, trying to make interoperable the research infrastructures, and I will dwell on that. And then, of course, to make interoperable and abundantly available fair data sets for creating the basis to exploit possibly automatic research workflows to actually change the paradigm or improve the paradigm of science. So let me start with a classic example of something that has already happened. Just a few years ago, you know that there was a big discovery about the existence of gravitational waves, something that had been looked for ever since the prediction by Albert Einstein, and the search for the gravitational waves went through several generations of detectors, and eventually arrived at this current generation, which is the long arm interferometers, and there are some of them. They are L-shaped. Two in the United States. They're called the LIGO. One is a European one. It's in Cascina, near Pisa, and it's French-Italian, but in fact European Virgo consortium. And then some, let's call smaller ones, are present in Japan and in India. The reason I'm mentioning this is because the very delicate detection of gravitational waves implies that you are sure about your observation if more than one detector does the observation simultaneously. And this has created, in a science endeavor where there is competition, the competition was eventually won by the Americans who got the Nobel Prize, but in such endeavor of competition, there is also a need of collaboration through the most efficient real-time data exchange, because it's only if all the detectors, or more than two or possibly more than three detectors, measure the event at the same time, that the statistics of the measurement becomes reliable, and that the confirmation of the event, so the verification of the reproducibility of the event, is obtained. So in this particular case, they had a very efficient communication channels. They do exchange the data in real time, and they cross-check the data analysis. So it's a large amount of data. It's not a huge amount from these detectors, but anyhow, it's a large amount of data that is shared in real time, analyzed in real time. Analysis results are again shared and produce eventually the result. So all of that has led to this fascinating, in this case, result, and something more. The event was immediately communicated to a large number of telescopes in the electromagnetic spectrum on Earth and in orbit. And these telescopes could be aimed within seconds to the sector of sky where the gravitational wave was coming from, that had been detected, was coming from. And that made possible to observe phenomena that follow the collapse of those neutron stars that determined the big gravitational wave pulse and signal. So again, real-time exchange of data, coordinates, and collection of data of different origins across the whole electromagnetic spectrum. In principle, neutrino detectors could be triggered as well. Cosmic rays detectors could be triggered as well in order to produce a better picture and better science, because if you have more observations of the same phenomena, you have more constraints to a coherent interpretation of what you have observed, which is a real step ahead. So again, here we see the need, including in this particular case, it's not always, but in this particular case, the very fast, so real-time coordination of many laboratories in the world, exchanging the data needed for the coordination, acquiring the data, and then later, of course, making available analyzed data to combine all together in building knowledge. So I chose this example because it's probably it's in the memory of everyone who have heard about this multi-messenger science. Multi-messenger science means multiple detectable signals that may arise from that are thought to arise from the same fundamental phenomenon, and that are required in order to address the interpretation and the understanding. So this example, in fact, can be somehow generalized. Somehow all science or much of science is becoming multi-messenger. Let's look from the very large to the very small, to the case of nanoscience, for example. There you have many techniques going from microscopy to spectroscopy. We have large-scale facilities that are specializing in producing, for example, X-ray beams of nanometer footprint, nanometer size, capable of doing spectroscopy on very small objects. But again, this is complex science, and one has to know about the sample synthesis, the growth conditions, the sample environment condition in which some measurement is done, the condition in which the electron microscopy with atomic resolution has been done on the same system that has been also measured by X-ray scattering or by neutron scattering. and so on. And this, again, means a large amount of metadata and of data that have to be easily combinable in order to come to some interpretation and some understanding of this nanostructure. So it's not enough understanding comes from one method. If many methods are applied on objects that we are not sure that they are exactly the same, the research is difficult. If we can be confident that they are exactly the same because we have all the metadata and all the conditions very well described, then our interpretation will have more constraints and probably go straight to fuller understanding or to real knowledge. Moving from information to knowledge, of course, takes into board the work of the researcher who interprets and proposes his understanding, and this is reliable if the data set is reliable. Sometimes people speak rather of reproducibility of the data. Again, to reproduce an experiment, you have to have all the metadata of the previous experiment that you want to reproduce, and then you can challenge the quality of the data, or then you can confirm what was observed, or you can find something more on the same subject. So this introduction shows the need of digitalization at a first level, of having the data, sharing the data, accessing the data, and operating on the data with the full metadata support. And this is in this direction that the EOSC is contributing a piece of the journey, a part of the journey. The EOSC at this time is organized as a tripartite governance with a large investment of €1 billion managed by the Commission and an association that represents the research performing organizations and the research infrastructures of Europe dealing with data science. And so together, association and Commission have started this co-program European partnership that will last the whole Horizon Europe program, and that has about €1 billion worth investment for the EOSC. And the EOSC, of course, has the ambition to provide European researchers, but as well as innovators, companies, citizens with a federated and open multidisciplinary environment to publish, to find, to use and reuse data with supported by tools and services for research. There are, of course, discussions and engineering processes ongoing on how to make it work. But what is interesting here to say is that if we had such a federated research data infrastructure, we will make a step ahead in the direction of the digitalization of research. And the current effort, the current challenge is to try to have the first operational version of the EOSC node, so the so-called core functioning in the next very few years. And so there are a number of technical things, both technology about running an open science cloud, and technology about how to finance that. So 2 million researchers in Europe will be the users, the potential users of that. And this means that if EOSC will be effective, at least in making the FAIR data set available to these 2 million people, a step ahead in the digitalization of research will definitely occur. But here we find immediately some challenges. So one way to describe is to say that the EOSC will become a sort of web of research data, research digital objects, if you include the services, the codes, the analytics that is needed for using the data. But in order to make sense of all of that as an effective contribution to the digitalization of research, we need a massive systematic production of FAIR data sets. And this is an important point that requires a technology effort and an important investment. In fact, I hate to use this word, but unfortunately it's in the business now. The fairification of data, of research data, so making a research data set fair, is an extremely tedious and costing process if you do it a posteriori. So if you take a data set and then tell to your colleague or to your PhD student, now for couple of weeks you work on making the data fair instead of doing the next experiment or writing up your paper, you will not be successful. But it's not only a sociologic thing, it's really a matter of the fact that the amount of data is growing, new detectors, new experimental setups produce more and more data. And if we don't have a technology to keep the pace of that production, then the EOSC risks to remain marginal, to operate only on a marginal amount of the new data. So fair data productivity is an issue, and fair by design technology is a title for the moment, but has to be developed. The laboratories, the observatories, the computing centers that run simulations as well should develop a methodology such that the original data are collected along with all the relevant metadata, and the FAIR data set is compiled immediately at the time of the observation, at the time of the computing, with only a minimal intervention by the researcher and only a very high-level intervention of the researcher to validate the data set. So this is, again, it's easy to say, but it takes an investment, it takes engineering, it takes software development, it takes a large number of extra sensors that are typically not available yet in standard research laboratories. But I think this is a bottleneck that we have to address to go towards the digitalization of research, because it's only if the FAIR data sets will be abundant and ideally corresponding to all the new data that are being produced, that the next step, that is efficient machine learning, efficient artificial intelligence algorithms can operate and deliver a new digital paradigm for doing the research. So large fair data productivity, large amounts of data sets are the goal. And the whole EOSC, in my view, will be successful on one hand, but also fully justified if it goes along with this high data productivity program. Although this is not exactly in the strategic plan of EOSC, but has to be added as a goal of digitalization of research. Right, so artificial intelligence tools may be leading to automated research workflows. EOSC needs abundantly rich EOSC for operating. Then there are a huge number of issues connected with EOSC, with openness or restrictness when necessary, and these are issues of debate and again engineering. So the way all this is going to happen is designed this way. There is a minimum viable EOSC plan to be ready within 25, 26, 27 at the latest, and is built around a core that is a basic series of federated services of different origin and made operational with different geometries, but that anyhow should be viewed and governed as a single element at the service of European research, and as a single element with a clear financing perspective. EOSC is expected to be a public good. We want it to be a public good. All the data we are talking about are basically coming from publicly funded research, and so they are by definition a public good. They are operated by researchers of public institutions and universities, and therefore the control and the organization must remain in the hands of Commission, member states, associate countries, as they collaborate for that. This is challenging on several levels. Governance is an issue because we need to have the core as an operational service, not as a project, and of course the full access to that. So the strategic agenda of EOSC implies, in order to have such digital services in place, a number of things that I will go through quickly through them, like federating data from, so all the metadata and research outputs should be such a way to be harvested with a cross-search system, and this is necessary to enable discovery and use of data. But the data will be at different institutions, will be sometime in domain-specific institutions or national repositories, and so all this has to be federated in a functional way. The so-called EOSC exchange or the marketplace of services and resources for EOSC, it's also something that will provide the possibility of brokering of community services among the participants and give access to procurement contracts. So all these appear to be details, but in fact are parts of the engineering of the minimum viable EOSC, and that they all carry challenges. These are matters that will be discussed in the tripartite conference, but you see immediately that national service providers need a mandate to provide service to organizations in other countries, taxation, procurement rules, management of the funded services are problems to be addressed to make it working. And the key of all is the interoperability. The whole story of EOSC and the real challenge is interoperability. It's a real challenge because the expectation is that interoperable data sets might be used by people from communities that may be not only different, but even far away from the community that has created the data. And so new knowledge could come out from using this data in supporting research aiming at different aspects of knowledge with respect to what was the primo motore of the research that generated those data sets. But this is the very difficult thing because there are no real examples. We have large research infrastructures that manage to explore interoperability within their own user community, so among different instruments, among different methods used by the same research community, but there is not yet much experience in how to do it for faraway communities. Neighboring communities, there is some work ongoing. The clusters of research infrastructures identified by ESFRI and supported by the European Commission represent, in fact, already some effort to become interoperable within, say, the sector of the health and biological sciences, or within the sector of environmental sciences, or within the sector of analytical infrastructures for physics, and so on. But cross-domain, when you cross really very different domains, is something to be learned. There is no experience also because there was never in the scope of the budget of a research infrastructure to make data that should be interoperable by a community that is totally external up to now to the interest in the data for that infrastructure. So there is a challenge there, and again, it's a technical, scientific, and managerial, so to say, or governance challenge. The rules of participation to the EOSC are again at the basis of the working agreement that may generate an effectively federated EOSC, as well as the relationship between the public efforts, the public investment in the data, in the fair data, in the open science, and the role of commercial sector partners or actors that must be controlled to be sure that everything is coherent with the public nature, the public good nature of the EOSC. And then there are data sovereignty issues that are also important, but you recognize probably from your direct experience that the number of issues to be addressed in order to make a data space suitable for digitalization of research are several, like semantic interoperability, semantic artifacts. So in the perspective of cross-domain interoperability, semantic artifact catalogs, machine-readable models of knowledge, controlled vocabularies, ontologies are needed. And this is not something off the shelf that you can simply purchase, but they require research. But at the same time, this should become operational soon. Otherwise, the thing doesn't work. So there is a strain there. Machine actionable repositories, this is also something that is going to be needed, in particular if the data set volume will be very important. The fair data set volume will be very important. And so, again, it's an investment. It's a software development to do that, whilst guaranteeing to the researchers that they will find a place to deposit their data, because this is what is called the last resort data repository or stores. It's an important thing because you want to set up a system where all the new data are added to the common wealth of this data space, but this must be doable at all levels. So again, you see political and organizational aspects. One aspect that is emerging, well, it's obvious from some point of view, but it's also emerging because of the general context in these unfortunate years, is the security. So security of the EOSC in standard terms, of course, has to do with the authorization authentication infrastructure and a number of methods and rules that you are probably very familiar with. But there is another level of protection that has been named the sovereignty on fair data by the steering board of the EOSC representing the member states, who have addressed this with one issue in mind, that is the active protection of the data quality. So we need to have a check of data quality for entering the EOSC or entering any data space that will be then accessed by the users or by their machines that will be the reservoir of information for digitalized research. But then you have to protect the data quality through access, reuse, and analysis and possible modifications and possible intentional or non-intentional corruption of the same data sets. And so the concept of sovereignty implies some level of control, and all of this makes the as open as possible, as restricted as necessary puzzle a real one. And again, technology, policy, and some invention should go into that in order to work. So now you will forgive me for skipping some slides that are not relevant for us today, or at least this morning. And I stop for a moment on this one, because along the digitalization of research, there is not only EOSC. There are a bunch of initiatives, you count there at least 10 or 11, that the Commission is supporting in order to create data spaces, sectorial data spaces. And so you see on the Green Deal, on transportation, mobility, finance, energy, agriculture, public administration, skills, etc. And of course, EOSC must be the overarching data space that can access and intercept all the other data spaces that are being set up for the research purposes. EOSC is the open cloud for research and science and innovation. And this is non-trivial because, for example, I put a circle on the health, is the European health data space, is the first one of these other 10 that is almost coming, I wouldn't say coming online, but coming to a full definition and with full engagement by the member states. So resources will be poured into this. It has certainly many good reasons to be a sectorial data space. The health data may be subject to the GDPR, so the protection of personal data, to avoid possible violation of privacy and so on. But so it has some intrinsic features that are typical of the health domain, and so makes sense to have their own data space. Nevertheless, it's very important that these data spaces are structured to be truly interoperable with the EOSC, don't develop in fully independent methods, protocols, choices, even at the, at all levels of the organization of the archives and etc. Because anyhow, with the fair data systems, you can always set a openness or restrictness at the level that you want, but openness and restrictness may be time dependent. There may be data sets that need to be protected for some time and then can be released. And the moment they are released, they should be immediately accessible because they are built the right way, and not they are released but unuseful because they are built in a non-compatible manner. And this is a real risk, because if you imagine the investment, the overall investment is important. It intercepts different ministries. So there is an issue at the governmental levels to know that when you speak about a data space and with the Ministry of Economy, they should know that EOSC exists as well, and that some solutions are being worked out, although there is not necessarily an effective communication channel between the Ministry agriculture or industry and the Ministry of University and Research. So again, opportunity and challenges to make it work. But I do believe that if all of these will come in place, and the EOSC should be the first one to get at least to this level of minimum viable operational setup, and if we find the right way to govern that and the right solutions, but the right solutions are probably not a big hazard, because as a federation of what works, EOSC should just provide an overlay on this federation to make it appearing to the user as a smooth, seamless interface of access and of activity for digitalized research. So if all of this works in the short time, I think the next evolution of digitalized research through a all new combination of machine learning on fair and reliable data sets and new experimentation and new analysis by the researchers might produce something that is very new. The least we can expect is an acceleration of the research process. In some cases, think of combinatorial chemistry approach. It can be probably extended to many other domains through machine learning, again, only if abundant and fully reliable fair data sets are available. But if they are, even in the domain of material science, probably accelerations of even an order of magnitude in time needed to find what are the subset of the possible parameters that are most promising for adapting a new material to a device or something like that, will certainly pay back. And at that time, the whole system will pay back, because if with the same research resources, the research productivity could be multiplied by a factor, then you have a big gain. And this gain is likely to pay back for the effort and the investment in setting all of these up. Okay, so I think I will stop here. Thank you for your attention and look forward to your questions. Thank you.